Hello. Okay. Good afternoon. This is Dequan Chin from Mayo Clinic. I'd like to present our securing enterprise healthcare big data by the combination of Knox gateway, F5 balancer, Ranger, two-factor authentication, plus Kerberos coupled with enterprise Active Directory and AirDAP. This is the subtopics I'm going to present. One is about the data security. It's critical to the Mayo Clinic success. And the second is the Mayo Clinic big data clusters and the evolution. And the third is the critical part is how we secure enterprise healthcare big data on Mayo Clinic Hadoop clusters, and also ongoing and future direction, plus the conclusion. Mayo Clinic, as many people know, is world largest non-profit healthcare. So the critical to the Mayo Clinic healthcare business success, one of them is the data, plus is the data security and data governance. Really, Mayo Clinic healthcare is integrated with research and education. And Mayo Clinic is the world's largest integrated not-for-profit healthcare system. We have more than 70 hospitals and clinics. We have the enterprise core value. The needs of patients come first. Every year, Mayo Clinic provides care for more than 1 million patients from all US 50 states and more than 150 countries in the world. Every day, our healthcare generates large amounts of electronic health record data. In the past, we call it electronic medical record data. Those data are structured data, or semi-structured data, or unstructured data. Many people of you may know that the Mayo Clinic Rochester, Minnesota is recognized as the #1 in the base hospitals of list of USA for 2014 to 2015 and 2016 to 2017 by US News and World Report. Here, this photo is, you can see Mayo Clinic Rochester will have 2 campuses. One is Methodist Hospital, one is St. Mary Hospital. Both are in the Rochester, Minnesota. The bottom line picture is our St. Mary Hospital campus. In the Mayo Clinic, for the enterprise healthcare big data is on our Mayo Clinic Hadoop clusters. Those data is in HR7 messages, or their parsed data. Parsed data mainly is structured data, or their JSON derivatives. Those kind of data, HR7 and the JSON derivatives, are a mix of semi and unstructured EHR data. Those data is for clinical usage, including for diagnosis, treatment and prevention, or clinical reporting. Well, also it will use for non-clinical usage, for research, business intelligence, or health information with like an insurance company or government agencies. In the Mayo Clinic, data security, enterprise big data security are needed because of the data we have PII data, or called personally identified information data, and the PHI data. PII data is really any data that can be used to contact, locate, or identify a specific individual. Those either by itself or combined with any sources of to identify those individuals. It may include data through like a financial, medical, education, or employment records. Some of the data elements like might be used to identify certain person, including like fingerprints, biometric data, a name, or telephone number, an email address, or social security number. And the federal laws, the following 6 federal laws really require any company to handle PII data securely, including like a healthcare, like a federal law is HIPAA, and also Privacy Act, GLBA, FOPA, and COPPA, and FCRA. Those kind of federal laws required to handle enterprise data, like PII data securely. Also in healthcare data, it has protected health information data, or we call it PHI data. Those data is any health information that is individually identifiable and created or received by a covered entity. This entity can be any of the following, like a provider of healthcare, or health plan operator, or health clearing house. It may relate to an individual's present, past, or future health information, or include like a physical or mental information, or even current health condition information. It is either maintained or transmitted in any given form, like a speech form, or paper form, or electronics form. But it doesn't include any like PII data, like include education records covered by the Education, like Family Rights and Privacy Act, and also exclude employee record data. Those data are not counted as PHI data. Federal law required to handle PHI data securely by HIPAA. Now I'm talking about the Mayo Clinic big data clusters and the evolution. Our Mayo Clinic big data clusters is we bought the hardware we bought from Teradata is we call the Teradata appliance with SUSE Linux enterprise server, because we use Teradata to handle those kind of hardware, so it will free our problems from hardware maintenance. Each Hadoop cluster covers those one Elasticsearch cluster on selected edge nodes. So really our big data cluster, it has both Hadoop cluster and the Elasticsearch clusters. We also have separated HD5 or NiFi clusters, not provided here. And for Hadoop and Elastic clusters, currently we have 7 clusters. For normal cluster, we have sandbox for discovery, and also we have development clusters and 2 test clusters. Originally, 1 test cluster we used for the disaster recovery cluster, but recently we resigned for 2 test clusters. And also we have production clusters. And for the HADR, DR means disaster recovery, we have the development cluster and the production clusters. Really, the big data stored in our Hadoop cluster and the Elasticsearch clusters, we have permanent data and temporary or permanent data. Like permanent data really is in the HDFS folders and the files, and the HBase namespaces and tables, and the Elasticsearch indexes. And for the Hive database and tables, we use for temporary, currently for temporary data. In the future, when we turn the ACID, probably in the future we'll use for permanent data storage. Since 2014, when we go to production, so we already experienced 3 years of Hadoop cluster experience in the production. The Hadoop in the Elasticsearch cluster evolution, we experienced those kind of version. Like for HDP, originally is Teradata modified and certified Hadoop cluster. HDP cluster is 1.32 version, where at that time our Elasticsearch is 1.0.1 version. And that version is uncooperated, so it's unsecure. And the second, we destructively upgraded to 2.1.2 TDH or HDP version, while Elasticsearch we upgraded from 1.32 version, and then we upgraded another version to 1.5.2 version. Those is also uncooperated version. After that, we upgraded to HDP 2.1.11 version, and Elasticsearch 1.5.2 version. This is enterprise secure, but it uses Kerberos' local KDC, not enterprise KDC. And plus, where Elasticsearch cluster is secured by Elasticsearch Shield via AD and AirDep. And recently, since last year, we update upgraded to 2.4.3 HTTP version, while ElasticSearch will upgrade from a variety of version from 1.52 to 1.72 to 2.12, 2.32, and recently we upgraded from 2.4.1, but the 2.41 Elasticsearch is not stable, so we upgrade to 2.4.4 version for production. This is also enterprise secure. It's very like a complicated security, not a local KDC, is enterprise AD and LDAP. And recently, for our new clusters, we use HTTP 2.53 version with Elasticsearch, the latest stable version, 2.4.4 version. Here is talk about a little detail about securing our enterprise healthcare big data on Mayo Clinic Hadoop clusters. Here you can see the components in our Mayo Clinic Hadoop clusters. In the middle, you can see it's from Ambari UI. You can see the different components. It's about more than 20, I think close to 25 components in our production Hadoop clusters. Here we don't show like the Falcon. In the 2.3 version, we have Falcon, but Falcon is 2.34. After that, it's not usable, so we disable the Falcon. So and on the right side, we have Elasticsearch clusters. You can see lots of from Mayo Office of Information Security or the Mayo property, any critical information we cannot show to the public. So here I use access YYRR or whatever to block those kind of information. On the left side, we also, our cluster is the top part is we use HTTP provided the version is 2.6.0 version of Hive for the interactive operation on Hadoop cluster. On the bottom is the latest Hive version is 3.12 version, but HTTP only provide this version, so we install ourselves. All those kind of versions of different Hadoop clusters, all the components is enterprise secured at Mayo Clinic. The major security adopted on Mayo Clinic Hadoop clusters is the following. The first is Kerberos security. We coupled with Enterprise Active Directory AD, use AD KDC, not a local KDC. And also we coupled with lightweight directory access protocol LDAP, OSSL. Those include critical HTTP services plus ElasticSearch services. Here we have about 8 components. I will detail later. And we also use two-factor authentication login and limited Sudo capability post OS-Hardening. This is only for limited number of authorized user applications on our local entry nodes, and the root login disabled. We also use a range of plugins and policies to control the authorization and the auditing. And for HDFS, Hive, and HBase data operation, we have to force user to use logs gateway and F5 balancer. First, let's see the Kerberos with Active Directory, and the Kerberos they use Enterprise AD KDC. Those, because we use the Enterprise KDC, it will provide a host of extensions and conveniences, such as password expiration and account lockout. So this is much easier than the local KDC to manage the key tabs and the different user accounts. And also for the users, you have to do the authentication and authorization. And so any Hadoop cluster, like any components in the Hadoop clusters, the services, you access the data or services, you have to do authentication and authorization, go through the AD. And for the user authentication, you can use two-way. One is we call it AD user principal name plus password. So here you can say when a user after logging into our edge nodes or entry nodes, we call it. So here what the critical access Y is blocking information. So you have to do the keynet. After you keynet, means then you have to put the user's password, then the AD will grant whether you can access the Hadoop cluster services. After finish, then you can use key destroy to to eliminate the authenticate. Another way you have to use user principal plus key tab. Key tab, any user password you can change to key tab, or plus the services of Hadoop clusters you have to use can use key tab. So like this here for like HDFS headless key tab, you can use keynet / the key tab file plus the principal name. Or you say the domain name and the principal name, I block it. So after finish, you can also use KDSOI. But after the Kerberos with Active Directory, the critical things you have to have auth to local rules needed for different like components in the Hadoop cluster, like HDFS, Uzi, Storm, Kafka, Ranger KMS, and Atlas. Those kind of critical components, all of them you have to have, like currently in our Hadoop cluster, we have 27 auth to local rules. So that, because these rules have to peel off the domain or the host name part for the user, so that the user will be authorized and authenticated and authorized. Otherwise, your Hadoop cluster will not work. You cannot access any data or any services. Second, we talk about the air depth and plus SSL, we call the HDFS. User authentication and authorization for some critical Hadoop components and plus ElasticSearch. We have to do the air depth over SSL. These components include like Ambari, Ranger KMS, Knox, Grafana, Atlas, Hive, and ElasticSearch. Hive really not belongs to HTTP, although HTTP provided. Like you see here, after we also use the for SSL, we use not a self-signed certificate, we use enterprise certificates in the Mayo Client, we call the Mayo Client Commodore certificates. After you successfully secure those components, so all the web link is HTTPS, and also the lock is green. Otherwise, it's broken lock. Like Ambari, Grafana, Ranger, Atlas. So those components plus the like Hive and the ElasticSearch and the logs. Logs you can go to different, like logs go WebHDFS, WebHCAD, and WebHBase. So all those kind of things you can use a web browser or use a curl command. Curl command not necessarily go through Hadoop cluster internal. You can even Windows command now any server you provide the curl like API, so you can access to the Hadoop clusters. So but you have to provide the like a credential, username, password. But those credential is like secured because it will automatically SSL handle those kind of security. Also, we do the OS hardening. After OS hardening, for user, we have to even go to our edge nodes. We have to use two-factor authentication. Like those, only for limited number of local users on Hadoop clusters. First, we disable root login, so no root login can log in. So only the administrator can log in with their own credential. After credentials, then can go to Sudo to the staff. But if first, any user log into our entry nodes, you have to do the two-factor authentication. First, use your local user's username password. Then you have to use like a passcode generated on the fly from your mobile device. Mayo Clinic authorized. We have a software called ISA. This ISA generated on the fly, like in 1 minute. It's working only in 1 minute. After 1 minute, those numbers change to another numbers. So this passcode, after you input the passcode, it will working. After you successfully log in with TFA or two-factor authentication, only small number of users, including our supporting people, so administrative people can do the Sudo capability, while all the others no Sudo capability. After that, any user wanted to use Hadoop service or data operation on the cluster, they have to do the Kerberos authentication against AD, like you have to do keynet or use username password, or keynet use username plus the key tab. We also use a range of plugins and a range of policies to control our authorization of a single user or group users of operation on the specific data and or services, like the data in the HDFS files or folders, Hive database or tables, HBase namespace or tables, or solo collections or documents, Atlas metadata. Those you have to go through user or group authentication. Plus the services of like Yarn, Storm, Kafka, Knox. Also, you have to go through the Knox authentication, go through range of policies. If no range of policies, even people has the AD authentication, but they cannot access any of our data or services in the Hadoop clusters. This is an example of HDFS policies. You say, in a Hadoop cluster, you can create a large number of Hadoop policies. Each policy is to a different granular level, single file level, or different folder level, or a combination of file or folder levels. So, and beside the groups, you can give to different groups or different users, or just some users, or just some groups. So there are a variety of HDFS or HBase or Hive policies. This is just a single policy. You say all the critical information I already a policy name I already block it. So then for this is a Atlas policy. For the Atlas, you say we give those for those different HDFS folders, and for the two users. You say one user is a user 00A, user 00Y. This is not the actual user like this. We have to change it in consistent with Mayo Office of Information Security. Ranger also performs data or service auditing. So example of HDFS user try to access Hive services. You say here is denied. You say I run on May 25th, 2017. So there is a HDFS user try to access our Hive services. So it is the service name and also from which client IP address, those it will show automatically. So in the Mayo client security, Office Information Security require all the data operation for any user we have to keep 7 years. So those kind of ranges auditing give us a good opportunity to preserve those kind of data for auditing data. Also, we use the Knox gateway for HDFS Hive HBase data operation. This is required for majority of Mayo Kinetic big data clients. It doesn't matter if it's users or applications. And besides, at the same time, for the non-secure Hive shell, we have disabled. Here, originally for the Hive command line operation, I force user to use BLAN. And no key tab issued for HDFS Hive HBase data operation by client application outside the Mayo Kinetic Hadoop cluster. Originally, a regular HDFS remote Java client use key tab, we disable. And Hive JDBC remote use key tab, we disable. And HBase Java client use key tabs, we don't allow. So the HDFS, Hive, and the HBase via Knox gateway, so it will change it to use WebHDFS, WebHCAD, and Knox Hive JDBC, plus WebHBase for data operation, respectively. For high availability, we achieved the use 2 or more WebHDFS, WebHCAD, or WebHBase, or Stargate HBase services on the master nodes. So for each, for example, for WebHBase, we at least we have 2 Stargate HBase on different servers for the underlying WebHBase HA. And for Knox Hive JDBC, if it's enterprise SSL, so it just needs users AD username password. If it's a self-signed certificate in the past, when we have one version, it was also needs the trust store and the password. plus the AD username and the password. Over the Knox gateway, we also Mayo Client will have the enterprise F5 balancer over 2 or more Knox gateway services for each Hadoop cluster to use to achieve Knox gateway services HA. And this F5 balancer, it provides more protection because it has a firewall and other security operations for user to connect to the F5 balancer. So here is an example for WebHDFS like HA for F5 and Knox combination for those kind of any HDFS, Hive, and HBase data operation. For like each F5 balancer, underline it use like at least 3 or more like Knox gateway servers. For each Knox gateway server, it use 1, 2, 3, or at least 2 like those of WebHDFS servers. So this achieve high availability. So like here, give some example for data operation via F5 balancer or Knox gateway. So here we just show like the WebHDFS data via web browser or curl command. First, you say for web browser, you say here where you say the F5 balancer YYY comma port 1. This is not real, like because Mayo security don't allow those. And the YYY is the class Hadoop clusters like a service name, so it's not real. So when you use in the web browser, after you type this command, then it will ask your username and password. So after authentication and authorization, it will give the results like here in the blue part. Also, if you go just use like another like a Knox gateway like a ZZZY or Knox gateway ZZ2, so you can get the same results. So you say you can use F5 balancer and the Knox gateway itself. But currently we use both for clients to use. But in the future, we highly recommend just users to use F5 balancer. You can also use like a curl command from any server, any places to access. Like use a Coup, IKU, and access is like use the username. You can also use the username plus the password and the Xgate and the air, then plus the HTTPS like the command, then you get the result. And similarly, you can for the change those kind of HTTPS web UI, change it to the Knox gateway 1 or 2, you get the similar results for the similar HDFS file. Then how WebHDFS data operation via Knox gateway work? It's really require like complex authentication and authorization process. Those require 2 range of plugins to work together. One is the HDFS plugin, and the second is Knox plugin. The HDFS plugin allows access to the HDFS data, while the Knox plugin allows access to the HDFS interface through Knox. The access path is likely to be in the following. First, a user connects or authenticates to Knox via HTTPS. Here, the SSL protects the credentials, so it will like hide the credentials. And also then the Knox checks the user's credential via air depth. After that, Ranger Knox plugin allows to access WebHDFS, Ranger Knox service level, just the Ranger Knox service level authorization. After that, Knox authenticates to AD, so the Kerberos attacks Knox credentials. And the AD will grant Knox a ticket granting ticket, we call the TGT ticket. After that, Knox will request a WebHDFS service ticket from AD. Then AD will grant Knox a service ticket, we call the ST, for WebHDFS. After that, Knox will pass the users as a proxy user to WebHDFS. Then the user tries to access the HDFS file, like an XYZ file. Then Ranger HDFS plugin, after that we'll check if a policy exists for the user and the HDFS file XYZ. This we call the range of HDFS authorization. At the same time, HDFS will check the native authorization for the user and the HDFS file XYZ. If both matches, it will issue authorization. Otherwise, it will issue deny. Only when the authorization is issued, then data in the HDFS file XYZ is retrieved and returned to the client application. It doesn't matter if it's a web browser or a command line. At the same time, our ElasticSearch cluster data is also enterprise secured. You can use REST API via web UI or curl command to get data. You see here is a simple, the first one is the HTTPS via web browser. You get the same results as use curl commands. Those is kind of JSON documents. You can also use the Java API via transport TCP. Here, the critical sense is after you secure with AirDep and AD, so it has for the ElasticSearch Shield, it will provide an interface to accept the user's password and username and password string. We call this here. Then after that, you have a ElasticSearch setting. The setting will take the username password like a string. So after that, it will generate the ElasticSearch transport address instance. This instance will take one or more like the ElasticSearch transport TCP host plus the host port number. So then after that, you can generate the ElasticSearch client. This client can have one or one to more, depends on how many ElasticSearch cluster nodes you have. So those, so that you can add the HA for the ElasticSearch through Java API. After that, you can generate use a scroll response to plus the query builder and plus the ElasticSearch filter to search the ElasticSearch cluster. So it is very fast, like a millisecond, you can get the results. Then you can after that you can loop through your results and to do any application. So after we enterprise secure our Hadoop clusters for the big data, currently we still do the two things as follows. The first one is big data network segmentation. It's whitelisting. This will generate a list of Mayo Clinic healthcare business allowed URL or IP addresses. This is Hadoop cluster specific and service specific, like for Ambari, for HDFS, for Uzi, for Falcon, for Atlas, for difference. So this is Hadoop specific, and also for user application client computer specific. So we just give to the users allowed to access our big data cluster data. So those computer specifics, their IP address, so we put them into the whitelist. So it will be implemented by Mayo Clinic network team and our big data technology services team. We only permit data or service operations by any user or client via the allowed list of IP connections, while block all the other connections. This is the one way. The other way we are ongoing is big data at rest encryption enhancement. We have currently already have drive or disk encryption. So anybody, even if they steal our data centers, big data nodes, so those data they cannot get it because it's encrypted. And also we have client managed encrypted HDFS, Hive, HBase, or ElasticSearch data. Those policies we still continue to extend in the future. But we still haven't largely enforce range of KMS managed encryption keys and data de-encryption for HDFS, Hive, and HBase data in the encryption zone, because originally we have the version of HTTP 2.3 version. That version and the early version, the HDFS data in the encryption zone, you can retrieve from the command line, but you cannot get the data from the Knox gateway. We also use the Teradata and Hortonworks to help us, but they can figure out that version, so we have a Jira for those. So hopefully in the latest version, 2.5.3 version, we can succeed for this, but we haven't fully tested for those yet. So that is ongoing. Overall, currently for the enterprise healthcare big data security at Mayo Clinic, I think we can draw the following conclusions. The first is the clusters has been successfully protected by the following components. One is the enterprise Kerberos, one is the Active Directory, one is the AirDep OSSL. Third, the other one is the OS-Hardening plus the two-factor authentication. And also we use Ranger plus Logs Gateway and F5 Balancer. Currently, it is still on the way at Mayo Clinic to enhance the enterprise healthcare big data security by the network segmentation and the data at rest encryption via Ranger KMS. The great thing is, so far, we achieved successful data operation on enterprise secured healthcare big data. So many people may know that after you do the enterprise secure for the big data, the data is too secure. It's hard to use. So the data operation is the hardest. So after we secure, now we already figure out for all this stuff for our clients, including a variety of clients, so to use the data operation for different data platform, even ElasticSearch clusters. This is the reference. The critical one, I think, is PHOI, plus the Hadoop stack and the Elasticsearch. And also the one is the recent computer science paper I published on the top IEEE journal. And this is a big, highest impact journal on the IEEE. IEEE currently has more than 135 journals. So we get our work, past work published in this journal. And in this paper, we also talk about the data governance and data security and the data privacy and all those kind of things. So thank you for your attention. If you have a question, please let me know.